quick screencast to help you on your way with the tasks of drawing energy diagrams. Now, we're going to just go through the basics of energy diagrams and talk about how they're going to be different between version 1, which is the one that I gave you to build, and version 2, which you built after you changed something, okay? So when you changed either the mass, the angle, or changed the friction mats, you ended up with version 2 of your machine. So both version 1 and version 2 have their own energy diagrams. But let's just take a look. Now, to get you started, when you have an energy diagram, you have to think of where you start, where it goes. So I've got here a little bit of a outline here, or a scaffold. So first of all, where did we start? We started at the top of a ramp. Okay? So if you're at the top of a ramp, what type of energy do you have? Well, first of all, your energy is going to be some sort of, I shall take that away, some sort of stored energy. In other words, it's going to be some sort of potential energy. That's what you're going to have when you start off, some sort of potential energy. Now that potential energy will then change or transform into a type of action energy called kinetic energy as it goes down the ramp. And in a perfect universe, all of that potential energy would then transform into all of that kinetic energy. Now the type of kinetic energy it is and the type of potential energy it is, I'm not going to tell you. You need to try and put that in. Now, you then had the marble continue to move unless for some reason it stopped, which most of them didn't by the time you guys fixed up your machines. It kept on moving and it kept on going down into the tube. And as it was going down that tube, it continued on as kinetic energy. It kept on dropping. So essentially, some of this potential energy was already transformed into kinetic energy by the bottom of the ramp, but then it dropped again. And the kinetic energy kept getting bigger as it gets down to the bottom of the tube. However, we are not in a perfect universe, and as you know, there's an awful lot of wasted energy here, okay? Now, because of that, you actually have to try and mark on here what type of energy is actually coming out, okay, at each of these sections. So in the tube, in the ramp, what type of energy is it losing because it is wasted? And remember, when we say wasted, it means it's not to our purpose. Now, our purpose was to get the marble going as fast as possible. So there are some energies that it can transform into that will not help speed up the marble. If it won't help speed it up, then it's wasted energy. Okay? You have to write them in on your energy diagrams. Okay? Now, I was just going to go into a little bit more now on how you then add in version 2. Because essentially this one here, that is version 1. Okay? That's version 1's energy chain. It went from the top of the ramp, then it went down the ramp, and then it went down the tube. That is my version 1 energy chain with some added stuff in there that you need to do. However, we then went and changed something. So for version 2, you were asked to then change something. You were asked to either change the mass of the marble, change the angle of your ramps, or change whether or not you had some friction mats in there. And version 2 then has to have its own little energy diagram. Now, you can actually either, in a different color, write over the first one that you had, so that you're clearly showing how it's changed it, or you can write this completely afresh. We don't mind. But you need to now talk to me about how your change actually changed this diagram. What you did here, how did it affect this? Okay? So that's what we're talking about now. So when you think about it, How does mass change anything? Well, think about the old adage. The bigger they are, the harder they fall. And that is actually very, very true. Because your mass increases the amount of energy you start with. Okay? If you have bigger mass, you're going to have more potential energy to start with. You are going to hit the ground harder. Okay? Angle also does this. Think about angle. Okay? If you're traveling down a steep slope, you're going to have more energy at the top and therefore more energy when you get to the bottom than if you actually only went down a tiny slope. Why? Because look here. What's different? Your height's different. You think the further you fall, the harder you fall. Everyone knows that one. The further you fall, the harder you fall. Okay, so it affects, again, your starting energy. Last but not least, friction mats. We put them in there quite specifically to slow the marbles down. Why? Because I had marbles going so fast that they were actually shooting off the marble run before they even got to the bottom, and we had marbles flying everywhere, so we had to slow them down. We had to steal some of their energy. So friction mats actually affect how the energy is wasted. Now, how you then take that information and communicate it to me in a new or improved energy diagram, so I can see how version 2 was different than version 1, is up to you. But there is the scaffolding for your energy diagrams for version 1 and version 2.